Okay, good. So I now have glorious unfiltered internet.
Leave where it's at, and I'll put this in there and get it so that you can start.
This one or this one?
I did the thicker one.
Okay. I don't actually need to have the sound up, but it's kind of useful just to detect when those people are going to be irritating each other. All right. So let me pull up the project of interest, which is P8X. It's the one I want to show you. All right, this one here is a listening server up here at attack 3214 direct. Although actually, let me check. I thought I updated that. Yeah, attack 32 direct. Okay, I updated this today. So there are two servers, but this one server should work. This one can be annoying, but if you want to not go out of your mind, as I mentioned, the most important thing is don't use Kali as the target. That made me baffled for the last 2 days as to why this is supposed to be easy, but it's impossible. Kali is not the same as Ubuntu anymore. It used to be, but it's not. So I went and got real Ubuntu here. Now here, you can download the source code and the compiled object code from my server. So you're running exactly the same binary, and yet that doesn't seem to mean that the heap layout is the same. So that was a surprise to me, but that's the way it is. So here I have Ubuntu. I should be able to make that bigger. Yeah, and I should be able to make the window bigger. Ubuntu actually has VMware tools that work, so I do not need to use SSH to get in, which is luxurious. Well, now I'm pretty much used to it. So I have P8X here. So you can run P8X, and it has a help message, which is you have to be listening on a port number. Yeah, see this is actually a self-contained program that listens on a port number. Now, this time I didn't know how to do it from Python and run it through Apache. So this actually has one process listening on a port, and when you crash it, it really crashes. And then it doesn't restart for a minute. So that's why I have 3 of them running on different ports. So anyway, let me first show you the remote one here, which is this. So here's my server. I bring it up here. Okay, so here I am right on the Mac. If you connect to that, you get nothing because apparently that one's crashed. Let's try 8011. Oh, maybe I'm being blocked by something in the system here. What's that? The server is down. Well, it wasn't earlier today, but it's down now. Okay, we'll use 3214. There are 2 servers, each running 3 copies of this. 32 was up earlier today, but now it's down. 32 is very vulnerable. People keep hacking it, and I keep patching it, and so that's why 3214 is less vulnerable. Anyway, so this thing has a string. I can put in a string, and it will echo the string back. Okay. It also prints ESP, because I thought you might have to adjust your exploit, but now I've learned you don't have to do that with heap exploits, which is handy. So this reads in data and echoes it. Now, to test it, what's easy is to run it on Ubuntu. So run it here. First, make sure this is on the internet. And it is, that's good. Then get its address. Okay, this thing is 172.16.1.254. That's my local Ubuntu. So I'm going to run P8X and listen on, say, port 2000. So now I'm running a copy of this server locally to practice on, which is, of course, what you want to do. And so I could do it from here, and maybe I will. That would be fun. I'm just going to do it straight from my Mac. Let me go into Downloads and 127. All right. And make this bigger. Without even using a virtual machine here, I should be able to exploit that Ubuntu machine there and ultimately the real server. So first, let's just connect. Oops, get rid of this nonsense. Okay, have to hit this to get out. Okay, so netcat 172.16.1.251 on port 2000. That should be that server. Okay, so now I can enter a queue to quit, and that lets me out. I can connect in again. Now, if I put in more text, it just echoes it without crashing. So the first thing, of course, is to fuzz it. So let's make, see what we got here, good nothing, nano fuzz. 1. I'm just gonna say print A times 1,000. That'll probably do for starters. And now I'm going to run Python fuzz. Okay, that prints 1,000 days. Now I can just pipe that through netcat. This is the fun way to do it. Netcat. That'll feed that to that program. And now, close failed in object disruptor. I don't know what that's about. Maybe I did something wrong. Maybe someone on the chat knows what to do here. Local host. Yeah, did I put local host? Oh, local host. Thank you. It's not local host. Good. I appreciate it. It's 172.16.1.251. Let's try that. There we go. So I put in something, and now it crashed. Segmentation fault. So 2,000 is enough to kill it. That's a good start. Good. Let's see what else we got here in the chat. Yep, the IP address. Yes, good. Thank you, folks. I appreciate the tips. Good. So now, so now I knew 2,000 is enough. Let's try 1,000. Oh, that was 1,000. All right, let's try 500. All right. And I'm going to have to restart it here. Okay. Come out of there. Run 500. 500 seems to have done some harm, but it didn't simply crash it. It did something awful. So let's go start it again. And let's try 550. Okay, that's also doing that horrible stuff, which is irritating. And I don't remember seeing that before. Makes me a little nervous, but let's carry on and try 560. See if, as I remember, oh, let's try 660. I think that's going to hit the sweet spot. Yep, 660 gives me a core dump. By the way, this is an important thing I mentioned before, and here's an example. You often find several different crashes at different lengths. So you have to find one that works and then always send in the same amount of data to make sure you keep hitting the same crash. There was something there that just went over and over again, and I don't want that. That's annoying. This one here looks pretty good though, 560. So let's check it in the debugger. If I do GDB, and I run it in quiet mode on P8X, and then I run it in 2000, it's listening on port 2000, so now I send that 660, and it crashes, and this looks pretty familiar. This appears to be crashing inside the free function from a heap, because I've seen this several times, and I can check that by doing x10i eip minus 10, and you'll see that it is in fact crashing on that same instruction again, move EAX to indirect EDX, which is good. So EAX is AAA, and EDX is AA. So here we are. A length of 660 has the desired effect that I have, it's crashing, and I control both ends of that. So there is actually somebody who sent it in my email. There's a Kali Linux tool to create a long non-repeatable pattern, which you can do if you like. I just prefer to write my own, but that's all right. Now, so I've got my first fuzz that worked. So I'm going to copy that fuzz to E1. That's my first attempt to write an exploit. So 660 worked. So what I'm going to do is make a prefix of that and a post of that. And I'm going to have a variable for the total length, which is going to be 660, and everything I'm going to keep the length total at 660. So now I'm going to print my attack. And I'll just do it this way. Let's see, I got a chat message coming in. MSF create pattern. Okay, good. Yeah, that's the tool some people use. I like to do it myself, but that's certainly, that tool is an option. So minus length of pre minus length of post. Okay, now I print. Oh, I don't want to print. I want this to be attack, say. Probably, yes, I should. Yes. Good. And now I want to print pre plus attack plus post. There. And by the way, just as a little bit of handy command line kung fu, if you Python, they spell it better, fuzz, it prints this junk, you can pipe that to word count minus character. And it'll tell you how long it is. It's 661 because it's 660 plus a carriage return. And it's a good habit to check your exploit before you waste your time and make sure it's the right length because it's easy to be off by a little. So this is also 661, which is good. So it should hit the same crash, except I put some special characters at the start and the end. So that's E1. So let's restart it here in the debugger. Okay, and then send E1 up there. So I go back to here and I send E1. And oops, I went to WC-L. I want to go back to the netcat. There, this one, E1. Okay, there now it crashes at the same point, which is good. If I do this, it's now 0, 1, 2, 3 here and 41, 41, 41, 41 there. So the first one I control, which is the data to be written. So let's get out of this. Nano my E1. Okay, so this hit, but the second part did not hit. And I see another chat message coming in. What is the code of PAX? It's on the project page. Yeah, that's right. You can get it, but I'm actually not even using it at this point. You don't even need it, but you can see the source code there if you want to. All right, good. All right, so this post wasn't working well enough. I need a longer post. So let's make post equals 5 times post and see what happens. And the length will automatically adjust. Let's see if that does it. And okay, good. All right, good. Just checking the chat. So let's see what this does. I send it to the server with that. I have to restart the server first. Okay. I send it here. It crashes. Now I still have AAAA there. So I'm not hitting it yet. Let's try again. I know it's under my control. I just need to make this long enough. Let's make 25 times post. That's 250 there. That should work. That should put a whole bunch of them at the end. And that's going to send it. This is going to run it. Okay. Okay. Whoa. When I go back and forth, I hit control keys and they foul up this thing. That's why I kind of got used to using SSH to avoid this nonsense. Now I finally made it. Okay, now some of those numbers end up in EDX and some are in EAX. And if I do examine 1I, EIP, I seem to have hit a bad place to crash. So I think what I've got, it could have a bad character, but I'm not sure that I'm really crashing where I want to. Let's do X 10I, EIP minus 10. Okay, it is on the move EAX to EDX. I don't know why this didn't work, but anyway, this worked. Oh, this is right. Oh, I'm just reading it wrong. Good. All right. So I move EAX to EDX. All right. So EDX is the destination address. All right. Now, I'm not sure I want to go much further than this, actually. That's enough to get you started. Let me just make sure I've talked about what's going on here. Okay. So here's my sloppy exploit, which you could make prettier, but I've now put 250 characters of 0124 in the post. Some of these post characters ended up in EDX, which is the address to write to. So to finish the exploit, you need to change this to an address that will point to the heap of where you inject the code. And you need to find out what part of this long tree hits EDX and change that to an address that's used by the code later. So I can keep going if you want, but it's really the same process of what we already saw. Once you have this, you know you've got it. Now I have an arbitrary write from A to D, and I control A and D. I just need to clean up my attack code to find out exactly which 2, 3, 4, 5 this is. I know what the 0, 1, 2, 3 is, and then just disassemble. But this is all you need. When you make your Python exploit, I just mentioned a couple of cruel things that might frustrate you here. Make sure you notice this thing says press Q to quit. So you have to not use a small q or a capital Q in your exploit, or a 0. Those are bad characters to avoid. That's annoying if you don't catch on to that. You can't use zeros, capital Qs, or small q's in your exploit. If you do, it'll terminate it, and you won't see it. And when you're done, you can get a shell on the server. One thing about it, though, is this is just 3 processes running on each of 3 servers, and as people attack them, they do tend to crash them. So when everybody's doing it all at once, it may slow you down because you have to wait 1 minute for my cron job to restart them. But for that, there are 3 processes on 8010, 8011, and 8012, and there's another 3 on the other server, attack 3214. So that's the one I had to use here, because, but anyway, give it a shot. The other ones are easier. And I'll just mention, although I don't think I'm going to go through it today, 5x. Here's another CTF problem. This is a Linux buffer overflow, actually the old stack buffer overflow, and the difference here is there's a canary value. Now, canary value is a value placed at the end of the stack to detect buffer overflows. But canary values can be defeated if they're predictable, and I think this one's actually fixed all the time. So all you have to do is not overflow the stack, look and see what's there, and then when you overflow the stack, carefully overwrite the canary value with the expected value. So check them out. Those are the extra credit ones. Yeah. What's what? CF8? CF8, you say?
Did you say CTF?
I don't know. What did you say? Okay, got a question I did not understand. Any other questions? Yeah.
One of the segfaults said core dump, where I know some normally doesn't say core dump. Is that different anyway, or is that just how the shell?
You can program the shell to make a core dump or not to make a core dump. And if you read the textbook, some of the exploits there, they like to make a core dump and then analyze the core dump. What we're doing here is the easier way. We just look at it live in GDB with a breakpoint. But when that's not available, making a core dump is a way to do it. And when we get to the Windows kernel exploits, we'll be using that technique, although it won't be obvious because we'll be using a Mark Russinovich tool that does it automatically. This is how you can debug the kernel on Windows without having 2 machines. You actually do a core dump and then look at the core dump. You're not looking at the live kernel.
Okay, so a core dump is like a static.
A core dump is just a memory dump. You see, when a machine dies badly, it crashes in the kernel, it will typically do a core dump, which means it dumps the contents of RAM in a file. So you can then open that in a debugger and analyze the dumped RAM. So it's a way to handle serious crashes that kill the machine. But everything we've done here has been user land. And in user land, you don't need a core dump because the kernel is still running and you can run tools like GDB. If you're debugging the kernel, then a core dump crash causes the kernel to stop running and that freezes your whole machine. So you either have to make a core dump or you have to boot your machine in debugging mode, kernel debugging mode, and connect it with a serial cable to another machine which controls it. And now, even if this kernel fails, your other machine can control it. That's the Microsoft solution, which is possible but very clumsy because computers don't have serial ports anymore. And what Mark Russinovich did was write a tool called LiveKD that automatically dumps the kernel and then lets you look at the dump. So you can examine the kernel without stopping it. And that means you cannot do as much as we're doing in GDB, where you put in a breakpoint and jump from one breakpoint to the next. But you can do quite a lot of kernel work with only one machine without having to have a master and slave machine. And that's the way we're going to do it. These are good questions. Any more questions? Well, I think that's it for today. I'm going to clean up here and go up to the lab. I'll be here till 4 to help people that want help. And here's some more questions coming online. I found a way to debug the kernel with a free version of VMware. Yeah, good. I appreciate it. There's a link he sent. Let me open this link and I can put it in the news pages. Animal Zero Day. Linux, oh good, Linux kernel debugging. Well, I'm going to save this link on the class webpage. I'll put it in my news and I'll put it on the 127 class. That sounds useful. I didn't know about it. I have not tried it, but it sounds pretty good. Linux kernel debugging with VMware free, good. I was able to do it, but it was very painful when I did it. You had to make these weird simulated serial ports and have 2 machines and stuff. You may have something better. Javier, okay, good. Any other comments? Perhaps not. Okay, I'm going to stop this and go upstairs and see if anybody wants help on projects up there. And if any of you know where we have a working wireless router,